Let R of t be a vector-valued function which is twice differentiable, meaning that each of the components is 2 times differentiable. So R of t rather is x of t, y of t, z of t, and twice differentiable means that x double prime, y double prime, and z double prime all exist. So you can take the derivative twice. And we would like to use the product rule for the cross product to show that the derivative of the cross product of r with its derivative is r with its second derivative. So the product rule for the cross product, the derivative with respect to t of r1 of t cross r2 of t, the cross product of two vector-valued functions, the derivative is the same as the ordinary derivative of a product. It's r1 prime of t cross r2 of t plus the reverse, r1 of t cross r2 prime of t. So this is the same form as the ordinary product rule. Of course, here we have cross products in the place of ordinary products in the regular one variable product rule. And these cross products are not commutative. In fact, they're anti-commutative. If you switch the order, you get a minus sign. So it's important to keep the order, the r1 prime cross r2 and r1 cross r2 prime. Those orders have to be respected. The plus, we do have commutativity of the addition of vectors. The cross product of two vectors is a vector. So we do have commutativity of vectors here, of a vector sum. So we could write this term first and this term second. But the individual terms, the cross product, the order must be respected. So let's see if we can calculate this derivative here. The derivative with respect to t of r cross r prime, according to the product rule, that is r prime cross itself plus r cross the derivative of r prime would be r double prime. And then a fact about cross products, the cross product of a vector with itself, u cross u, is the zero vector. And in fact, if u and v are parallel vectors, this is also true. U cross v will be the zero vector. So here we have a cross product of a vector with itself, so that's the zero vector plus this other vector, r of t cross r double prime of t, and this is, of course, r of t cross r double prime of t, and that was the right-hand side that we were supposed to obtain. So there it is. The derivative of the cross product of a vector with its derivative is the cross product of the vector with its second derivative. It's kind of a nice little formula.